Okay, so on 23, what kind of question is this? Do you think? What's that? Number 23? Oh yeah, 23. 23. What'd you say? It might be long division. I actually think, and I'm not sure, what would happen if I did long division? You actually couldn't do long division, Jordan, because if you set this up and your negative 3x squared, yada yada, would be underneath, and the first thing you'd have to ask yourself is x cubed times what gives you x to the second? And you wouldn't be able to do that, right? Nathan? You still wouldn't work. Try, if you want to play with that, it still wouldn't work. Yep. Factoring and canceling, just simplifying that way. So in the numerator, we would factor. It has to be negative 3x and x. It may also be positive 3x and negative x, but we can play around with signs in a minute. It has to be 2 and 1 or 1 and 2 to make 2. Which one do we want paired with the 3, the 1 or the 2? So we want 1 and 2. That would be a 3 and a 2. Our signs have to be the same, by the way, on the 2. On the 2 and 1, because it's a positive 2, so it's a double negative or a double positive. So if I do this way, does that check out? My outer gives me 3x, my inner gives me minus 2x. Does that check out? Is 3x minus 2x 5? Negative 5? No. So maybe they're both positives, because you were pretty convinced that that was the one, right? So now if they're both positives, that's a negative 3x combined with a positive 2x. Does that make negative 5? Isaiah? So do it this way and keep this one positive. And then this would be a positive 3x minus a 2x. Or should we go back to the double negative? So we have a negative 3x and a positive 2x. Still not working, right? I think the 1 and 2 needs to be flipped. 2, 1 will give us negative 6x plus 1x. That works. Yes? Follow? Guessing and checking, obviously a little frustrating in this particular problem. Remember splitting the middle term. I'm going to remind you of it. If you wanted to split up this middle term, you'd need to find two numbers that multiply to get negative 6 and add to get negative 5. What are they? Multiply to get negative 6, add to get negative 5. Negative 6 and 1, right? They have to multiply to get negative 6 and combine to be negative 5. 2 and 3, it's a tricky one because 2 and 3 make you think 6, but they have to be negative 6. So one with negative 2, positive 3, or positive 3, negative 2 kind of screws up the 5 part. So it's negative 6 and 1. So splitting the middle term, once you find those two numbers, I'm going to split up negative 5x into minus 6x plus 1x in group. So pull out a negative 3 because it leads with a negative 3x. You're left with x plus 2. Pull out a 1 for lack of anything else. You have an x plus 2. And you see the negative 3x plus the 1 and the x plus 2 that matches. So x plus 2 and negative 3x plus 1 in your numerator. Your denominator is just a GCF. If I pull out an x squared, I'm left with x plus 2. And so the x plus 2's cancel, and it's negative 3x plus 1 over x squared. What happened? Why is the answer not there? What did we do wrong? Negative 3x plus 1 and x. Was it an x minus? No, it's an x plus 2. plus 2 x squared x plus 2. And then I wonder if this is a mistake. It should be negative 3x plus 1 over x squared. I wonder if the answer is 2 and it's just a mistake. Because these are weird with negative exponents. That's like negative 3 over x plus 1 over x squared. Oh, so do you see how that, maybe this is it. So with the they're just writing it in a really funny way. So if I use my negative exponents and then I were to get a common denominator, like multiply this by and multiply that by x, that would turn into negative 3x plus 1 over x squared. Do you see that? Wow, that's annoying. Yikes. It's 4. If you wanted to cheat, if you had no idea how to do this, but you wanted to see which one was equivalent, pick an x value, like 5. Plug it in, see what the value is. Plug 5 in for your x for all of those and see which one matches. If you're really at a loss, right? There is a test-taking benefit, just understanding how to work around things. You can do that. You might even be able to pass alone just on doing that, truthfully. I hate to say that, but it's a fact. If you really didn't even take this course, I bet a lot of you could pass it just using those methods on September 1st of this year. Again, not that I would want you to do that, but in the 11th hour, if you're trying to make it, there you go. So on number 24, Jasmine decides to put $100 in a savings account each month. The account pays 3% annual interest compounded monthly. How much will she have after 1 year? So this is tricky because it's not like she's just putting in $100 as her principal amount and letting it grow. She is putting in $100 on a monthly basis. So the $100 that she puts in January, that is going to grow by 3% compounded 12 times over the 12t power, but that's just the original $100. That original $100 is going to compound 12 times. But in February, she puts in another $100, and that compounds 11 times. Yes? Do you follow? Okay? This one is I would say, the best technique for you guys, because it's maybe process of elimination first. This is just her putting in $100 and letting it grow by 3% 12 times in the year. That's not what's happening. It's that 3% is got to be divided into 12 parts. Not to mention we're contributing more than $100 just one time. This one is correct if she was only depositing $100 in January and never again. Because there's your original $100. There's your 3%, I believe, cut into 12 parts. 0.03 divided by 12. There it is, cut into 12 parts. So she's getting that percentage 12 times throughout the year. But that's just what January's contribution is doing. Again, they've missed the fact that it's each month she's putting an additional recurring deposit of $100 in. So we're down to these two, both of which are using a series formula. And if you look back in the beginning of your reference sheet, this is a geometric series they're using. First term, and then your rate to the nth power, 1 minus r. I'm trying to think if there's any reason we would eliminate. Both of their exponents are 12. Both of their hundreds. But one's using a rate of 3%, and one's using a rate of 0.0025. Which is it? Are you making 3% 12 times or 0.25% 12 times? What do you think, Isaiah? Yeah, this one. This one is showing you making a rate of 3% 12 times throughout the year. That's not the case. The annual interest is 3%. The monthly then interest is kind of, you got to work and divide that by 12. It's option 2. That one's tricky. If you were at a complete loss, you might just want to do it. and figure out what that would be approximately. We know the answer should be, how much is this person contributing in the entire year out of her pocket? $100 per month. $1,200. So there's at least $1,200 in the account. And then if you're only making 3%, if you were making 3% on that entire balance, that would be kind of $1,236 at around, if we were being very rough about it. You could plug in both of those and see which one is closer. My guess is this one's going to be way too high. Like if I do 100 minus 100 times 1.03 to the 12 and divide it by negative 0.03, that's a little bit high because that person made 3%. Yeah, Nate? No. Nope, good call. I wonder if the actual test was like that or if that's just the way it translated to this green book, but no. Okay, let's pause there for just 1 second and go over this. Given the sine squared plus cosine squared equals 1, find the value of cosine. You have the sine value to plug in, so it's, and do it in parentheses. I saw a lot of mistakes because people didn't square properly. And then we're just solving for cosine squared. When you square a negative, it becomes positive. When you square root 3, it becomes 3. When you square 5, it becomes 25. And that's unfortunately what I saw a few people miss anyway. And then solve for cosine, so we have to subtract over 3/25. So that's 25/25 minus 3/25 is 22/25. And then square root both sides, so the cosine of x equals, and it's plus or minus initially. Because cosine is in quadrant 3, what is it? Positive or negative cosine? Negative, so we would go with the negative root 22 over 25. To take the square root of a fraction, it's the square root of the numerator, and the square root of the denominator separately can be taken as just 5, so that the radical's just over the numerator. And then if this could be reduced, you'd go ahead and do that. Yep. Yeah, I'll compute that as well because it didn't say simplest radical form or anything. Now, this told you to use this. Well, it didn't actually. It said given. But on the test, it might say to use this, and that's the proper way. But as a checking mechanism, what is my go-to with trig? Always. Draw it. Okay, we're in quadrant 3. Draw it. Create your rectangle. You know that your sine is opposite over hypotenuse. So your opposite is negative root 3. Your hypotenuse is 5. Complete your triangle with the Pythagorean theorem. Root 3 squared plus x squared equals 5 squared. So this is 3 plus x squared equals 25. Subtract your 3 over. You're going to get x squared. You see where that 22 comes in. So square root both sides. X equals plus or minus root 22. Which is it since we went that way? Negative root 22. So the cosine adjacent over hypotenuse. Yes? Okay? That would be my go-to method just because I know we're better at that than we are at squaring fractions and squaring radicals and so on. But that is the answer. Okay, this asks us for independence. Number 1. Okay, I'm losing my mind with independence. It's going to be asked. There's going to be an independence question, or there's at the very least going to be a given question. So there's 2 must-knows for something like this. You have to know what to calculate to test for independence. If it's blue eyes and blonde hair. So you want to look at the probability of one of those on its own, and you want to compare it with blonde given blue. There might be half of you in here that did probability of blue on its own. Uh-oh. And compared it with the probability of blue given blonde. That's fine too, as long as what's alone leads the given. But let's focus on this one. So the probability that Gary and Jane have a child with blue eyes is 30%, blonde is 50%, both is 0.15. This screams Venn diagram. Blonde, blue. Blue eyes is 30%. I just don't know how that 30% is split up yet. Blonde is 50%. I just don't know how that's split up. But with both being 0.15, It's a kind of an easy one where I can now figure out what's the rest of the blue. If that has to get up to 0.30, then that alone has to be 0.15. If blonde has to get up to 0.50, that has to be 0.35. So the probability of blonde alone, look at your blonde circle, not only that, but they told us 0.50 versus blonde given blue. So given blue, you definitely have to know how to count. This I'm 100% sure is going to come up. It might be as simple as just find the given probability, or it might be in and amongst the independent test, but you're going to have to do given probability. Your denominator is this category. So your blue circle is 0.30. Your numerator is both 0.15. And when you check that, 0.50 equals 0.50. If they're equal, it's independent. If it's not equal, it's not independent. Okie doke. Systems of equations, 3 variables, elimination 3 times. So if we look at our x's, our y's, and our z's, which variable do you think is easiest to eliminate? I would say the x's. You could make them all 2's pretty easily, yes? So I'm going to use a multiplier. 2x plus 2y plus, there's obviously different ways to do this. The second one I'm not changing. The third one I'm multiplying by 2 as well. That'll be negative 2x plus 6y minus 10z equals 22. So we want to eliminate the x's by the first 2 by subtraction, so that'll be gone. 2y minus 4y is negative 2y. 2z minus 6z is negative 4z, and 2 minus 2 is gone. Eliminate your x's the second time by adding, opposite signs add, so we get 10y plus minus 6 plus negative 10 is minus 4z, and 2 plus 22 is 24. Now the third round of elimination is obviously in this case easier with the z's. Same sign, subtract. So negative 2y minus 10y is negative 12y. This minus this is gone. 0 minus 24 is negative 24. Solve for y. Y is 2. Go back. If 10 times 2 is 20. Solve for z. So negative 4z equals 4. Z equals negative 1. Go back. Solve for x. So negative 2x plus 6 times y. 6 times 2 would be 12. Minus 10 times z. Negative 10 times negative 1 is plus 10 equals 22. This is 22, so when I subtract 22 from both sides, I get negative 2x equals 0, so x equals 0. So 0, 2, and negative 1 for x, y, and z. Okie doke? Okay, last question on June, the 37. We'll get through whatever we can, knowing that it's a 6-point question. It's probably long. Do you notice how much exponent stuff comes up? It's crazy. Okay? This is radioactive substance of a mass 140 at 3 p.m. It's probably important. And 100 grams at 8 p.m. Write an equation in the form of this that models this situation where H is the constant representing the number of hours in the half-life. A sub 0 is the initial mass, and A is the mass T hours after 3 p.m. If they have defined that this is T hours after 3 p.m., what is our initial amount? What is it? 140. So far we have A equals 140, 1/2 T over H. How can we find our H? How can we find that? We've used this, 140 grams at 3 p.m. We haven't yet used this. Plug in your point. The final amount is 100 grams at 8 p.m. So what would you plug in for A? $140 is dropping to 100. And how many hours did that take? 5. And you would solve for H. So we divide by 140. So that's 100 over 140 equals 1/2 to the 5 over h power. Log base 1/2 on both sides. You go with that? Log base 1/2. And then we have 5 over h equals this crazy number. And we'll work on, I guess, solving the rest of that tomorrow. So, move on to August for homework.